here you have the sum of 1 over n times n plus 1, n starts from 1, goes to infinity. Very well. When you have a series like this, we're getting back to Math 1b and using partial fractions. First of all, what's the nth finite sum? N partial sum. The n partial sum S sub n is defined as the sum of 1 divided by I times I plus 1. I starts from 1 to n. If I write it in expanded form, it's going to be like this. 1 over 2 plus 1 over, if I plug in 2, I get 6. Then if I plug in 3, I get 12, and so on. It doesn't give me anything useful. Okay, so what else I can do? Let us use the partial fraction. The partial fraction says, hey, you have 1 over I times I plus 1, which is A over I plus B over I plus 1. So it means that A times I plus 1 plus BI is equal to 1. What's the meaning of that? It means that A plus B is 0 and A is equal to 1. So it means that your B is equal to negative. So this sum can be written as S of n equals to the sum 1 over I minus 1 over I plus 1. I starts from 1 to n. Now let us write this in expanded form. Here I get 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus the rest of the terms. And if I plug in n, I get 1 over n minus 1 over n plus 1. Okay, take a look at these terms. Negative and half, they're opposite of each other. Negative and third, they're opposite of each other. Negative fourth and the next term, they're opposite of each other. You have plus 1 over n, you can cancel it out with negative 1 over n, which is the previous term. So you're left with S of n is equal to 1 minus 1 over n plus 1. When you take the limit of Sn, while n goes to infinity, this is 1 minus 1 over infinity, or 0, so it is equal to 1. Since the limit of your partial sum is 1, you say that the limit of this series is also